Hello, my name is Daniel, and today we will be solving the AMC 10A from the year 2003, and let's get right into it. First problem, what is the difference between the sum of the first 2003 even counting numbers and the sum of the first 2003 odd counting numbers? Okay, so the first 2003 even would be 2, 4, 6, 8, 2, 4006, and then the first 2003 odd counting numbers would be 1, 3, 5, 7, 9, 11, all the way to 4005. So there will be 2003 numbers in total. So this and so the difference would be 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus all the way up to plus 1, which is 2003. Since there are 2003 numbers, so the answer is D. Problem number 2. Members of the Rockham Soccer League buy socks and t-shirts. Socks cost $4 per pair and each t-shirt costs $5 more than a pair of socks. Each member needs one pair of socks and a shirt for home games and another pair of socks and a shirt for away games. If the total cost is $2,366, how many members are in the league? Okay, so let's find the cost for one person. This is 2 pairs of socks and 2 t-shirts. So 2 socks are 2 times $4, and 2 t-shirts are 2 times $9, since t-shirts cost $5 more than a pair of socks. So this added together would be 2 times 13, which is 26. So what we have to do is, since the total cost is this much, we have to divide by 26. So 2,366 divided by 26. This is 9, 54, 18, 23, 26, so we have 91 people. The answer is B. Problem number 3. A solid box is 15 centimeters by 10 centimeters by 8 centimeters. A new solid is formed by removing a cube 3 centimeters on a side. From each corner of the box, what percent of the original volume is removed? Okay, so the original volume, this is 15 times 10 times 8, and the removed volume, this is, there are 8 corners, right? So 8 times, and then a cube 3 centimeters on the side, so 27. So 8 times 27 over 15 times 10 times 8. This would be 8 would cancel, and this 3 would be divided, so it's 5 times 10, 9 over 50, which is 18 over 100, so it's 18%. The answer is D. Problem number 4. It takes Mary 30 minutes to walk uphill 1 kilometer from her home to school, but it takes her only 10 minutes to walk from school to her home along the same route. What is her average speed in kilometers per hour for the round trip? Okay, so on average, it takes 20 minutes for one trip, right? So for 1 kilometer, 20 minutes for 1 kilometer, so kilometers per hour, so 60 minutes would be 3 kilometers. So her average speed is 3 kilometers per hour. The answer is A. Number 5, let D and E denote the solutions of 2x squared plus 3x minus 5 equals 0. What is the value of D minus 1, E minus 1? Okay, so since D and E are the solutions of dx squared. Okay, so if this is, okay, so D plus E would first of all be minus 3 over 2, and DE would be minus 5 over 2. So this would be DE minus D plus E plus 1, which is minus 5 over 2, plus 3 over 2, plus 1, which is minus 1 plus 1, which is 0. Number 5 is B. Problem 6. Define x heart y to be the absolute value of x minus y for all real numbers x and y. So which of the following statements is not true? Okay, so let's look at A. Since it's the absolute value, x minus y, y minus x is the same, so A is wrong. 2 absolute value of x minus y, so this would be 2x and 2y. So 2x minus 2y. Yeah, so it would be the same since 2 is a positive number, so B is also correct. And C, x, okay, so this is wrong, because if x because if x is less than 0, then let's say it's minus 3 heart 0. This would be the absolute value of minus 3 minus 0, which is 3, and this is not minus 3, so the answer is C. Problem number 7. How many non-congruent triangles with perimeter 7 have integer side lengths? Okay, so perimeter 7. For something to have a perimeter of 7, then it can only have 2, 2, 3, or 3, 3, 1. So there's only these two ways, and they're not congruent, so the answer is B. Problem number 8. What is the probability that a randomly drawn positive factor of 60 is less than 7? Okay, so the randomly drawn positive factor of 60. So let's just list the factors of 60. 1, 2, 3, 4, 5, 6, no 7, no 8, there's no 9, 10. Okay, and then since these are two are together, it's 12, and then it's 15, it's 20, 30, and then 60. Which among these is less than 7? So it's this one right here, so it's 1/2. The answer is E. Problem 9. Simplify this mess. Okay, so let's just start from the inside and work our way out. So x root x. This is so x root x is x to the 3/2 power, so x to the 1.5th power, and then cube root this. Okay, let's move things a bit down. So let's just, okay, so, and then cube root this would be 1/2 x, so it's root x, right? And then put x over it, then it's x times this, so it's x times this, so it's x to the 3/2 power. Oh, so it will be the same situation over and over again, right? So it is going to become x to the 1.5th power, root x, x to the 1.5th power, root x, x to the 1.5th power, and then root x. So it's root x. The answer is A. Problem number 10. How many of the 9 resultant polygons can be folded to form a cube with one face missing? Okay, so this just means that no overlaps. Okay, so let's just go into all of these in turn. If we put it here, then this and this will overlap, so 1 is out. If this is here, then these can't fold, so 2 is also out. If 3 is here, then this and this will overlap, so it's also out. If 4 is here, yes, then this will make a cube like this, with this side open, like this. Bad drawing, it's okay. So 4 works. 5 also works, and since 5 works, these all work, since when they're folded, they will all be the same square. And then since 4 works, 8 also works, and 9 also works. So there's 1, 2, 3, 4, 5, 6. 6 times, so it's E. Problem 11. The sum of the two 5-digit numbers AMC10 and AMC12 is 1, 2, 3, 4, 2, 2. Okay, so AMC10, AMC12 equals, added together is 1, 2, 3, 4, 2, 2. And then we can see that these two added together are 22, so you can just erase these. And so AMC plus AMC will be 1, 2, 3, 4. So AMC would be 1, 2, 3, 4 over 2, which is 617. So A is 6, M is 1, C is 7. You add them all together, it's 14. The answer is E. Problem number 12. A point x, y is randomly picked from inside the rectangle with vertices 0, 0, 4, 0, 4, 1, and 0, 1. Okay, so the vertices would be 0, 0, 4, 0, 4, 1, and 0, 1. So it would be this rectangle right here. And then what is the probability that x is less than y? Okay, so for that to happen, we need to see, we need the graph of y equals x equals y. So it's like this, right? And then this part would be 1. And so for x to be less than y, the point would have to be somewhere here, since this part is the part where x is less than y, right? So for that to happen, let's just draw it out to scale. This is 1, 2, 3, 4, and then what we need is this much. So this is obviously 1/2 over 4, which is 1/8. The answer is A. Problem number 13, the sum of three numbers is 20. The first is 4 times the sum of the other two. The second is 7 times the third. Okay, so if the last number is A, then the second is 7 times the third, right? So it's 7A. And the first is 4 times the sum of the other two, so it's 8 times 4, 32A. The sum of three numbers is 20, so 40A equals 20. What is the product of all three? A is 1/2, right? And then we need the product of all three, so it's 32 times 7 times A cubed. So it's 32 times 7 over 8. So this is 4 times 7. This is 28. The answer is A. Problem 14. Let n be the largest integer that is the product of exactly three distinct prime numbers d, e, and 10d plus e, where d and e are single digits. What is the sum of the digits of n? Okay, so if n is the largest integer, that is the product of exactly three distinct prime numbers, right? So like if it's okay, so n has to be the largest integer. So d has to be 7, right? Good, because that way this would be 7. So it's 70 something, and then it can't be 75, and it has to be distinct, so it has to be 73. Would 73 be a prime number? And 73 is a prime number. And so what is the sum of the digits of n? Okay, so n is 7 times 3 times 73, which is 73 times 21, which is 7, 3, 6, 14, 1, 5, 3, 3, 15, 33. So 1 plus 5 plus 3 plus 3 equals 12. The answer is A. Problem 15. What is the probability that an integer in the sets 1, 2, 3 all the way to 100 is divisible by 2 and not divisible by 3? Okay, so there is 100 possibilities to choose from, and then if it's divisible by 2 but not divisible by 3, so it's 50 are divisible by 2, but then out of them, the ones divisible by 3 are the multiples of 6, right? So how many multiples of 6 are up to 100? There are, it's 96, right? Divided by 6 is 16. So 15 minus 16, that is 34, right? So 34 over 100 would be 17 over 50, not 15, 50. So the answer is C. And what is the units digit of 13 to the 2003rd power? Okay, so for this one, we are just looking at the units digit. So it's the 3. The 3's pattern is 3917. No, 3971. 3971. So since 2003 is 4 times 500 plus 3, so it would be plus 3. So since the remainder is 3, it will be this one here. The answer is C. Problem 17. The number of inches in the perimeter of an equilateral triangle equals the number of square inches in the area of its circumscribed circle. What is the radius in inches of the circle? Okay, so the number of inches in the perimeter of an equilateral triangle. Okay, so let's just draw an equilateral triangle here, and then let's make of its circumscribed circle. So the circle would be like this. Right, just about here. Okay, so the radius would be like this. Let's say it's r. And so since this is 1/2 r, this is root 3 over 2r, and so the perimeter of the triangle, this would equal 3 root 3r, and then the area of circle would be pi r squared. So pi r squared would equal 3 root 3r, so pi r is 3 root 3, r is 3 root 3 over pi, so the answer is B. Number 18, where is the sum of the reciprocals of the roots of the equation 2003 over 2004x plus 1 over x equals 0. Then we would have to multiply by x to both sides, so 2003 over 2004 x squared plus x plus 1 equals 0. So 2003 x squared plus 2004 x plus 2004 equals 0. Okay, so yeah. So for this one, we would be able to do 2004 multiplied by x squared plus x plus 1. This equals x squared. So the reciprocals of the roots of the equation. So we don't need this. What we're looking for is if the roots are a and b, then what we're looking for is a over 1 plus b over 1, which is a plus b over ab. And so here, a plus b would be 2004 over 2003, so it's minus 2004 over 2003, and ab would also be 2004 over 2003. So what they're looking for is here, a plus b over ab equals minus 2004 over 2003 over 2004 over 2003. So these two cancel, this is minus 1. The answer is B. Problem 19. A semicircle of diameter 1 at the top of the semicircle of diameter 2. The shaded area is called a loon. Determine the area of this loon. Okay, so what we would need to do is make two lines right here and right here. Straight line. Okay, and then we would need to get the area of this triangle, add the area of this semicircle, and then subtract this 1/6 of a circle. Okay, so let's do that. And then, so the first thing we have to do is, since this is 1 and this is 1, we have to figure out the area of this triangle. So triangle is root 3 over 4 times 1 squared. So it's root 3 over 4, and this much. The semicircle, this is 1/2 times 1/2 squared pi, which is pi over 8. Okay, so and then what we need to do is subtract this much here. So this 1/6 of a circle would be 1/6, 1 over 6 times, since it's 1 pi times 1 square, this is 1 over pi over 6. Okay, so what we need is this plus this minus this. So root 3 over 4 plus pi over 8 minus pi over 6 equals root 3 over 4 minus 24 plus 3 pi over 24 minus 4 pi over 24, which is root 3 over 4 minus pi over 24. The answer is C. Problem number 20. A base 10 three-digit number n is selected at random. Which of the following is closest to the probability that the base 9 representation and the base 11 representation of n are both three-digit numerals? Okay, so it's selected at random, so this means that this is from 100 to 999. Then which of the following is closest to the probability that the base 9 representation and the base 10 representation of n are both three-digit numerals? Okay, so the base 9 representation and the base 11 representation of n. Okay, so for it to be a three-digit numerals, then for it to be base 9, so maximum is 9 squared plus, so it's 8 times 9 squared plus 8 times 9 plus 8. So this is 8 times 81 plus 9 plus 1, which is 8 times 91. So this is 728. Okay, and then so it has to be less than or equal to 728, and then the base 11. This means the minimum has to be 1 times 11 squared plus 0 times 11 plus 0, which is 121. So this has to be at least 121. Okay, so the probability that the base 9 representation and the base 11 representation of n are both three-digit numerals. This is there are 900 probabilities, so it's over 900, and then 728 minus 121, and then since these can both be the number of n, it's plus 1, so it's 900 under 728 minus 120. This is 608 over 900. Okay, so problem 20, this would be 608 can be divided by 90. No, it can't. So 608 over 9 divided by 9 is 5, no, 6, 54, 68, 7, 63, 5. Okay, so this is 67 point something something over 100. So this is about 0.7. So the answer is E. Problem 21. Pet is to select 6 cookies from a tray containing only chocolate chip, oatmeal, and peanut butter cookies. There are at least 6 of each of these kinds of cookies on the tray. How many different assortments of 6 cookies can be selected? Okay, so there are chocolate. Okay, so this is also stars and bars method. He has to select 6 cookies, and then at least 6 of each of these kind of cookies on the tray. Okay, so there are 3 kinds, right? Chocolate chip, oatmeal, and peanut butter. So we can have 2 of the bars. Okay, so the bars could be, so if the bars are apart, then they would have 1, 2, 3, 4, 5, 6, 7, right? So it's 7, choose 2. This is 7 times 6 over 2. This is 21. And then 7 and then bars together. This will be 7, so 21 plus 7 would be 28. The answer is 28. It's D. Problem number 22. In a rectangle ABCD, we have AB equals 8, BC equals 9, H is on BC with BH equals 6, E is on AD with DE equals 4, line EC intersects line AH at G, and F is on line AD with GF is perpendicular to AF. Find the length of GF. Okay, so AB is 8. BC is 9, so this must be 3, and this must be 5. Since this is a right triangle, this must be 10. This is also 8, so since this is 4 and 8, find the length of GF. So we're trying to find this length, right? And then, okay, so to get this, we first need to know, okay, so we can first notice that this and this are, the ratio is 5 to 3, right? But then this triangle and this triangle are perpendicular, they're similar, right? They're similar. So since this is 5 to 3, if this is x, x to x plus 10 must also be 3 to 5. So 5x plus 3x plus 30. So 5x equals 3x plus 30, right? 5x equals 3x plus 30. X equals 15. So this much is 15. And find the length of GF. Okay, so since this is 4 to 8, then by Pythagoras this is 4 root 5, and then since this is 3 and 5, GC to GE must also be 3 to 5. So if GC is y, then GC is y, then y to y plus 4 root 5 will be equal to 3 to 5. And so 5y equals 3y plus 6, no, plus 12 root 5, y equals 6 root 5, so y equals 6 root 5, and so now we can use the fact that CDE and GFE are similar, right? And so since the ratio is 4 to 10, so EC to GE ratio is the same as CD to GF, right? And so 4 root 5 to 6 root to 10 root 5, because it's the whole thing. This would be the same as CD to GF. But then this here is the same as 4 to 10, which is 8 to 20, right? So since CD is 8, GD is 20, that means problem 22, the answer is B. Problem number 23. A large equilateral triangle is constructed by using toothpicks to create rows of small equilateral triangles. How many toothpicks would be needed to construct a large equilateral triangle if the base has 2003 small equilateral triangles? Okay, so notice that for this one, there are 3. So for this one, the number of toothpicks are multiples of 3, right? Because we can have like one triangle each here. And so, since it says there are 2003 small equilateral triangles on the base, that base means there are 1002 of these upright triangles, and so what we need is, since this is 1 plus 2 plus 3, and then since the base has 1002, there will be 4 and then 5 and then all the way to 1002. How many would that be? So the number of upright triangles, total upright triangles would be 1 plus 2 plus 3 plus all the way to 1002. This is 1002 times 1003 over 2. This is 1003 times 501. So this is 1003 and then 500, 1003, 1550, 501500 plus 501500. So this is 502503. And then we need to multiply that by 3, since we're looking for the number of toothpicks. 3 times 502503 equals, let's get rid of these here, equals 390157015 1507509 1507509. The answer is C. Problem number 24. Sally has 5 red cards numbered 1 through 5 and 4 blue cards numbered 3 through 6. She stacks the cards so that the colors alternate and so the number on each card divides evenly into the number on each neighboring blue card. What is the sum of the numbers on the middle 3 cards? Okay, so she has 5 red cards. 1, 2, 3, 4, 5. 4 blue cards. 3, 4, 5, 6. And then the colors alternate. The number of each red card divides evenly into the number on each neighboring blue card. What is the sum of the numbers on the middle three cards? Okay, so for this one, we need a... Okay, so they will be... let's bring these a little lower. Then we will have to, like, split them. And then these should go into the space between like this. So this is what they mean by the colors will alternate. But then each red card will have to divide evenly into the number on each neighboring blue card. Okay, so if we have two with this one here, then two should be divisible. Then two should be able to divide into, so two should be a divisor of 4, and two should be a divisor of 3. But then 2 is not a divisor of 3, so that means that this arrangement is wrong. So we have to rethink the arrangements. Okay, so the first thing is that 3 and 3 have to be together, and 5 and 5 have to be together, right? Since they are both prime numbers, and it will be great if they have 1, because 1 can divide into anything. So it would be like that. And then 3 can also divide into 6, right? So 6 must be here. And since 6 can divide into 2, but not since 2 can divide into 6 but not 4, 2 should be here. And so 4 comes here, and then 4 can go into 4. So this is the finished this so this is the final arrangement. What is the sum of the numbers on the middle 3 cards? So the middle 3 cards are these 3. So it's 6 plus 3 plus 3 equals 12. The answer is E. Okay, so last problem number 25. Let n be a 5-digit number and let Q and R be the quotient and the remainder respectively when n is divided by 100. For how many values of n is Q plus R divisible by 11? Okay, so n is divided by 100 and Q and R would be the quotient and remainder. So n would be equal to 100 Q plus R. But then Q plus R is divisible by 11, right? So let's say Q plus R is 11k, where k is an integer. And so this would be 99q plus q plus r, which is 99q plus 11k, which is 11 times 9q plus k. So this means that n has to be a multiple of 11, right? And so for how many values of n is q plus r divisible by 11? So let's see, n is a 5-digit number, and so n is something, which has to be 10,000 to 99999. So the number of multiples of 11 in this range would be the answer. Okay, so 1 to 99999 multiples of 11, so this would be 99999 divided by 11, 9090. So this would have 9090 multiples of 11, and then 1 to 10,000, no, 1 to 9,999 would have 9999 divided by 11, 909. So this would have 909 multiples of 11. So what we need to do is this subtract this, since we want the numbers of the multiples of 11 in this range. Okay, so 9090 minus 909 would be equal to 8,181. So the answer is B. And that was the problem. Thank you for listening.